Hi guys, Norm with you again, and you join me at the messy bench. And today we're having a look at this Farnell E30-2 power supply, which has been my lab supply for quite a few years, and it sadly went faulty. I hadn't used it for a long time because I've been ill, and when I come to fire it up, it was dead. Absolutely no good at all. No voltage output. And so I've done lots of investigating on the schematic. Here's the schematic. And I will upload the full service manual, which I have got. And what it turned out to be was transistor, this one here, focus, VT5, which is a 2N1893, which is this little focus, this little transistor in here, and that was found to be blown, and so I replaced that with a so-called genuine Motorola part, and the genuine Motorola part was a fake, and it started doing all sorts of crazy things. The voltage was going up to like 65 volts and back, and it wasn't tracking linear with these adjusters or anything. It was all gone to pot, and then it smoked another couple of components, and so that would give me quite a bit of a hassle. So what I've done is I've recapped the whole thing. I've put new capacitors all over it. Apart from these two ceramic capacitors, they both test fine, so I've left them in. And ceramic capacitors don't normally go too far out, so that's okay. So I then replaced this with I managed to find 4 new old stock SGS Thompson transistors. Just trying out the phone a bit steadier. And so I put that in, and then it was working, and the voltage was tracking perfectly, but it was only doing like 1 volt or 2 volts. And so we had to continue looking. And then over here is, can we see that there? Z4 was found to be shorted, so replace Z4. That is 5.1 volt Zener. And as it happens, you never have what you need in the box. I didn't have any 5.1s, so I put a 5.6 volt Zener in there for now, and that has got the power supply back up and running, and it is tracking fairly well, linear. Not doing quite 15 volts as it should, or the full 30. But that's fine for now. It is back fully working, and I have ordered replacement Zener, 5.1 volt Zeners, and there's also a 10 volt Zener and 18 volt Zener on the board. I've ordered new ones of those as well, and they are here Z3. See, Z3 is another 5.1. Z1 is 18 volts, that's over here. Yep. And, yep, so that's good. And all those were emitted. These are 1N4003 resistors, diodes I mean, can't talk. And they've been replaced with 1N4007, which is basically exactly the same, or very similar. These are ZTX 107 transistors. They're VT1, VT3, and VT4. They can be and have been replaced with BC107. That's exactly the same. These are actually some Phillips parts, I think. I've got in there. Yeah, Phillips 10440. And that makes the power supply feel very happy indeed. So all I've got to do now is wait for the new transistors to arrive. No. Wait for the new diodes to arrive, and I'll put them in, and then we'll have to do a calibration to get it all back to spec. Okay, so here we can see the 18 volt diode is a MZ18TS. The 5.1 volt Zeners are IS2051, and the other one, wherever it's to, is a different number. And here's all the new diodes. These are all BZX55 diodes, and you see the different voltages, and so we'll stick them in and see how happy the supply is. Okay, so here's all the diodes we took out, and this is the 18 volt Zener, and as you can see, it broke into two parts when we took it out. I mean, it was in circuit and it was working, but obviously not quite right. So we've replaced that, and the 5.1 volt Zener and the 10 volt Zener there, and this is the 5.6 I put in place of the 5.1 to get the thing working the other day. So now we've got it all back in. You can see all the diodes in here. There's Z2, Z4, Z1, and Z3. So let's see if this thing works now, and how far out it is, or how close it is to spec, and whether we need to do a recalibration on it. Okay guys, so the service manual / user manual wasn't any use at all, or any help in the calibration for this thing, so we're going to have to wing it. Now we got this 5, see if I put the camera up there, focus. You got these 5 pots here, these 5 trimmers, and one will be for, I think this one will be for main voltage, and there will be one to offset the 15 from the 30 volt range. There will be one to set the actual meter, and there will be one to set the current limit, probably something like that anyway. So let's see what we're doing. We're doing 13.9 at the minute, and the display is reading about 14-ish. So we're start off on this. We're looking to go with everything set fine. We're looking for 15 volts, so hopefully this will change when I adjust this. Oh yeah, that wasn't a bad guess for the first adjuster, was it? Right, 15, let's set it to 15.0, it's close to 15.03, 14.99, oh, okay, 15.03 is near enough. So let's now check on the meter. It's reading just over 15, so we need to adjust that. And I'm guessing this one to adjust the meter. Let's see. Oh yes. Boom, boom, boom. We've got a bit of adjustment there either way. Can you see that? Yoy, yoy. So we're doing 15 volts on the output, so we need to adjust this to read that on. Let's get it bang on in front. So that is 15. So when I push the switch in now, we should go to 30 volts. And we've got 29.04. So that's close, but no cigar. And the meter's reading right. So now there's probably this adjustment to offset the this one here. See if this one does any offset. No, that's not changing anything. Okay, back to 15. Oh, that did change 15. Okay, so 29. 14.7. So we can now bring the main adjustment up a bit. Wrong way. Get on. 15.06. Okay, and 29.72. Okay, so I think the thing we've got to do is set this main voltage to 30. And then offset the 15 from that. There's 30.04. And the needle's reading a bit over, so let's pull the needle back. Get it straight on. 30. Okay, so now we go to 15 volts. And we're reading 15.2. The needle's looking at 15.2. So we just want to bring that down a bit with this part. 15.0432. 15.01. That's perfect. Then we've got we're showing just below 15 on the meter. So let's tweak the meter up a touch. Okay, reading. Let's bang on 15 on the meter. Now 1501. So let's now go to 30 volts. 30 volts there. And we're a little bit over on the meter. I wonder if one of these other ones just the offset the meter. No. And no. Okay, so just bring this back a touch. Okay, so we're reading 30 volts there. We're doing 30 volts on the output. So let's now go back to 15 volts. We're 1501. We're just a bit under on the meter, but that's near enough, I reckon. So what we've got here with the adjusters is this is the main voltage part. We put it on 30 volts. We adjust this to get 30 volts. And then we switch into 15 volts. And then we adjust this part to bring in the 15 volts environment. This wants to go up a touch, so it's just up a little touch. And we're 15.01. So let's see. Okay, we're just over the 30 and we're 30.04, so that's got all the voltages sorted out nicely. So now we have to do the current limit, and I'm guessing that these two are for the current limit, so I'll get out the dummy load and we'll see what's going on with it. And so just before we did that, I wanted to put it in lower voltage mode, take this down to say 5 volts on the meter. That's reading just over 5 volts on the meter. And what we got on the capacitor, on the flute rather, 4.98. So that's fairly good. Focus. As we go down lower, right down to 0. So can we get like 1 volt? Let's see. Not easy looking through the camera. I think that's higher. Down. So that's about 1 volt. And we're reading 1 volt on the fluke. So, yep, that's looking pretty good. Let's set it to, say, 10 volts here now. Then, okay, touch. Helps if I look at it straight on. 10 volts, near enough. And we are reading 10.03, so I'm happy with that. That's the voltages, all pretty good. And we're back up to 15. Yep. And we're 1501. So I've got to say, when I was adjusting it, the insides, I did have the fine tune set in the middle position. Obviously the coarse tune was set to full for 15 volts. So you want to do that so you've got a little bit of room either side. So we can go from 15.32 and to 14.61 with the fine control. So that's looking good. Okay, let's sort out the current limit. Alright, so we've got the little dummy load set up there now. Now on the 30 volt setting, I'm reading 29.6. It should be a 1 amp current limit, so it should cut off. That'll be one of these two. I don't know which one, so we're just playing with steam here at the minute. Oh, there we are. That's brought it back up. So we need to go now 6, 4. Well, let's take this to an amp. We can't, because there's a bit of fan noise there, so we'll have to ignore that for a minute. Right, 1.1. Well, I'm missing a lot of this camera, right? Over. Up, 1.1. Okay, 1.1. So we're putting 1.1 amps, so we just want it to shut off. So that's now if I bring it down just below and on. Over, so it goes over. That's okay, so we've got some in it. Okay, so we've worked out that this is the 30 volt adjuster to get the volts up to 30. This one is to offset the 15 from the 30. This sets the voltage on the meter, so you can line the meter with the output. This sets the current limit for both the 30 and the 15. It's not identically matched, so we are a little bit out. I mean, maybe changing one of these resistors would get it more into line, but that's near enough. And so this adjustment must be for the current setting on the meter at the front. So that's what we've got to look at now, is setting the current limit, or setting the current on the meter on the front. So let's come back to this now. Let's pull up to an amp. Where are we? Let's get it just down. Control on this dummy load isn't very. Okay, so whoops, come on. I'm going to get it to just about an amp. It's 1 amp, perfect. Now, I click this switch into amps. We should be reading 1 amp on the meter, and we're way off from that. So we're assuming that this pot sets that. So let's have a look, and it does. So we're going to go to go out. So we're going to go get it bang on straight. Right, 0.99 amps. We want it to go just on an amp, just about there. That's looking good. Now let's see if it goes. Let's go down to half an amp. Oh, wrong way. Go down to. I'm going to have to put a fine control on this dummy load. Come on. 54. Right, spoken segment 0.1. Okay, 2, 4, 6. Okay, so there. 0.2. So if I set that to there, that should be approximately 0.2 amps. We're at 0.19, so that's good. So we got a bit more. So that should be approximately 0.4, and we're getting 0.4, that's good. So 0.6, 0.6, obviously this is not entirely accurate, being a cheapy crappy Chinese thing, but it's certainly near enough. So let's go 0.8. Come on. Oh, get it. Up a bit, down a bit, up a bit. Oh. Ah, friggin' thing. Okay, so we're just over 0.8, and we're reading 0.81, that's good. So let's go all the way to 2 amps. Okay. Not entirely stable at that. And the dummy the load isn't entirely stable. Like that. That's certainly near enough. I mean, if I go now and just set it to 1 amp on this scale, so I put in 1 amp, and a bit down, a bit down, a bit. Whoa. Down a bit, down a bit. Okay, so I'd say that's about an amp. Let's see what we'll put in. 1.01. Yep. See, that's looking good. Okay guys, so that's the Farnell E30-2 power supply, all back up and running, thankfully, because that's, you don't realise how much you actually use something until it doesn't work, and then you're stuck. It's, oh no, but so now we're back up and running, and it's all looking as good as it can be. The current limit is a bit off on the 15 volt setting. It's now like 2.3 amps rather than 2, but that's fine. There's nothing wrong with that. We could muck around changing some resistor values to make it match up exactly with the 1 amp, 2 amp sort of limit, but that's fine. There is also the Farnell E30 without the -2, and that I believe only has 30 volts at 1 amp, on which this one has 15 volts 2 amps as well. So there you go guys, that's how to fix up your Farnell E30. Cheers for now. Oh, and by the way, it's Cornish law that if you put a thumbs down, you have to write in the comments why you dislike the video. And that's law, so thanks for watching guys, cheers for now. I want to go through, look at some of the schematic and tell you some of the things that are listed as incorrect or what have you. Here we have a C1 which is listed as 32 UF 64 volts. It's actually 47 UF 63 volts. Z1 is 18 volts Zener. Z2 is 10 volts Zener. Z4 is 5.1 volts Zener. And Z3 is 5.1 volts Zener. Here I think is R19. Yes, R19 listed as 470 ohms is actually 4.7 or 4K6. So that's that. I made a note here, if the voltage is low, check R4. That means if the meter is tracking fine, but you're only getting up to about 1 volt or 1.5 volts, then check Z4, because that could be faulty. That was what's faulty in this one. C8 here is not listed, but it's actually a 1000 picofarad capacitor. These ZTX 107 transistors, I've basically replaced those with BC 107. They're basically identical. What else? You've got R17 down here, which is odd because you've got R17 up here as well. Now R16 and 17 up here are the 1 ohm load resistors for the 2N3055s. This R17 down here, marked as SOT on the board, not exactly sure what that's supposed to mean, but that is a 1 neg resistor, so just to put that right. What else have we got? Oh yes, on the outputs here, it's listed as 100 UF 63 volts, well actually in the machine was 150 UF 63 volts in the supply, I mean.